I've mentioned before that there are 5 methods that you can use to solve a quadratic or solve some equation that has an x squared. We've learned 2 methods, graphing and square roots. Today we're learning the 3rd method, which is called completing a square. Before we get into that method, we need to review an idea that we learned a couple units ago, which was how to multiply something like x plus 4 squared. Remember that when you square something, you multiply it by itself. So I would have to write x plus 4 twice and then FOIL it, which just means distribute. So I'd take the x and I would distribute it to the second group, and that would give me x squared plus 4x. Then I would take the 4 and distribute that, and I would get 4x plus 16. I know that from there I would combine like terms. I'd put the x's together, and that would give me x squared plus 8x plus 16. Okay, so that's something we learned a while back. Now let's apply it to quadratics, what we're doing now with solving. Remember last lesson when we learned square roots, I mentioned that some quadratic equation like this one, I couldn't use square roots to solve that. It just would never work, and the reason is because of this 8x term. So if there's a b value, or basically if the b value is not 0, square roots doesn't work. So I'm going to say because, we'll say that like bx term, the one in the middle, that term right there makes square roots impossible to use. Now, the goal of today is to like change this equation so that way I can actually use square roots. So think about what we did at the top here. We could actually rewrite the left side of this equation, this x squared plus 8x plus 16. I can rewrite that because look at the top problem. That's what I got as my answer. So what I started with, that x plus 4 squared, that's the same thing as x squared plus 8x plus 16, just written out. So instead of putting that trinomial with 3 terms on the left side, I'm going to put x plus 4 squared in its place. It's actually just the same thing. Now, if you have a trinomial, so something that has 3 terms, if you have a trinomial that you can rewrite as a binomial squared, it has a name. It's called a perfect square trinomial, and the reason is because it can be written as a binomial squared. You guys have heard perfect squares before, like 81 is a perfect square because 9 times 9 is 81. So if there's something that you can multiply by itself to get that answer, we call it a perfect square. This is just a little different because it has x's in it, but x plus 4 times x plus 4 gave me this, so therefore this is called a perfect square trinomial. Okay, so useful information for you here, but here's what I'm going to do now. In this quadratic equation, which that's the goal, I'm trying to solve this, instead of putting the trinomial on the left side, I'm going to put the binomial squared. I'm going to set that equal to 0. Now I'm looking at something that I can use square roots to solve. And you guys were doing really good with square roots. You've seen that it's actually like pretty straightforward. It doesn't take long. So if I can change something to be able to use square roots, I want to do that because it's not going to be that bad of a problem. So here's how I would use square roots to now solve this for x. I would just want to get rid of the squared before I break up the parentheses. So I would square root both sides to cancel that out. Then I'd have x squared equal, or x plus 4 equals just 0. You don't need the plus minus sign because it's 0. And then I'd just subtract 4, and I would have my answer. X would be negative 4. Remember that you can always check your answers. That's the best thing about solving a quadratic. I could plug negative 4 into the original problem, and I would get 0. All right, let's practice a few of those. So again, the point of this is to take a quadratic that I would not be able to use square roots on, which this one I wouldn't because there's that 6x term. I'm going to change it, though, to something that I could use square roots on. So the goal is to rewrite this trinomial as some binomial squared. Okay, you know you're going to write it x plus or minus some number. You just have to find the number. So to do that, you have to factor this trinomial. Now this goes back to something we learned a couple units ago with factoring. To do that, remind yourself, you have to find, it's actually two numbers. These are perfect squares though, so it's going to be the same number, like 5 and 5, 7 and 7, whatever. So you're finding the number, the two numbers, that when you multiply them together, you get 9. When you add them together, you get 6. And it has to be the exact same number. So hopefully it jumps out at you. It's 3. 3 times 3 is 9. 3 plus 3 is 6. So I can rewrite this as x plus 3 squared. You could check yourself if you wanted to like actually FOIL that out. If you did what we did at the top here, you would get this trinomial. Okay, so if you need to check, do that, but it's x plus 3 squared. Once I've done that, then I can use square roots. So I would just square root both sides to cancel out the squared. And I would have x plus 3. I don't really need to write the parentheses, but I already did. And the square root of 36 is 6. Remember that every time you square root, you have to write the plus minus sign. Now, as you can see, there's actually two answers. So you need to write, and this is my suggestion, I would write two equations. Okay, and here's what the two equations are going to look like. X plus 3 can equal positive 6. X plus 3 can also equal negative 6. So I would write out both options and solve each one individually, and you're just going to subtract 3 to solve. So if I subtract 3 on the first one, I get x equals 3. If I subtract 3 on the second one, I get x equals negative 9. Now realize, you guys, that you can check these. I'm not going to for the sake of making this video shorter than it has to be. So obviously if I check every single one, it's going to be too long. But just to show you, I could plug 3 in. And you guys are good at doing this. And I do get 36. Do the same thing with negative 9. You'd get the answer. All right, I want you guys to try number 2. And I'll check that tomorrow when I check your notes. What happens now when the trinomial is not a perfect square trinomial? So like this one's a perfect square. I will tell you right now, this one's a perfect square, meaning you can just write it as x plus 2 or whatever. It works out nicely. You don't have to think too hard. So you're going to see some, though, that are not perfect squares. If this happens, you have to make it a perfect square, or you have to complete the square. What do you know? That's the name of the lesson, completing the square. All right, so one like this example down here. This is not a perfect square because there is no number that I can multiply it by itself to get 13 and add it to itself to get 12. It doesn't exist. So perfect square, it's not the case on this problem. I'm going to make this into a perfect square. Here's how I would do that. You have to move the c value to the other side. So in this case, that's that negative 13. You need to get that out of the way. So move the 13, or we'll say like this c value. And I would do that by adding, which they've kind of done for me here. So that would cancel that out, and I'd now have 13 on the right side. You're going to complete the square by putting the number here that would make this a perfect square trinomial. Okay, so I have to figure out what number needs to go on this line. What's it going to be? I don't know. Let's figure it out. I need to think about this. I need to figure out what number multiplied by itself would give me whatever goes here, and added to itself gets 12. So what number, when you add it to itself, do you get 12? Well, hopefully that answer jumps out at you. And I need it to add to itself to get 12. Fill that in. Has to be the same number. Otherwise, it's not a perfect square. Once you find the number, and I hope it jumps out at you that it's 6. 6 plus itself, 6 plus 6 gives me 12. once you find that number, you need to multiply it by itself to get what goes on the line, or I'm going to say you should square it. Okay, so once I find the number that added to itself gives me 12, I'm going to multiply it by itself or square it, so 6 squared. That gives me the number that I put on the line, which in this case would be 36. Okay, so 36 goes here. Oh yeah, so 6 times 6 is 36. 6 plus 6 is 12. Perfect. Now, we're not totally done. Realize that you can't just go adding a random number to one side of the equation and you're going to be good to go. No, whatever you do to one side, so if I add 36 to the left, I have to do that to the other side to keep this thing balanced. So once I do that, I can kind of simplify both sides. On the right side, I'd do 13 plus 36, which would be 49. On the left side, this is a perfect square trinomial now, so I can rewrite this as a binomial squared, and it would just be x plus 6 squared. So that was the whole point, to be able to rewrite this as a binomial squared, because now I can use the square root method. So I'm going to square root both sides, and I would get x plus 6 equals plus or minus, don't forget, 7. Now I'm going to do what I did on that first example. I'm going to write two equations. So x plus 6 can equal two different numbers, 7 or negative 7. So I'd solve both of these by subtracting 6, and that would give me 1 and negative 13. Okay, so again, you can check these. I got negative 13 was one of the answers. So let me come back to the original problem. And just for fun, let's make sure it worked. And I got 0. Okay, so don't settle for wrong answers, especially on quizzes and tests. Check your answers, make sure they work. All right, I'm going to do a couple of these. Ooh, don't cut off your X there like I did. I'm going to do 1 and 3, and you guys are going to try 2 on your own. So maybe you want to watch me do 1 and 3 first before you go back and hit 2. Here's what I'm going to do. So it's a process that takes practice. The first thing I want to do, if I notice this is not a perfect square, and yeah, there's no number that I can multiply by itself to get 45 and add to itself to get 18. Maybe 9 would jump out at you because 9 plus 9 is 18, but 9 times 9 is 81, so that's not going to work. So I need to move the 45 to the other side. And that would give me x squared plus 18x. I'm going to leave a space because I'm going to complete this square by putting a number right there. It's going to equal negative 45. All right, you got to figure out what number completes this square. So again, we looked at the middle number and we thought, what number added to itself gives me 18? Well, I kind of already said it. 9 plus 9, that gives me 18. Okay, so once you find the number, 9, you have to square it. Remember what we did here? We squared it or multiplied it by itself. So 9 times 9 is 81. That's the number that completes the square. Whatever you add on the left side, you have to add on the right side. So now I can rewrite this trinomial as a binomial squared. Found the number, it was 9, so I write x plus 9 squared equals, let's see, negative 45 plus 81 is 36. Now I can use the square root method. And I get x plus 9 equals plus or minus, don't forget, 6. So I'm going to write two equations. X plus 9 can equal 6. X plus 9 can equal negative 6. When I subtract 9 in both equations, I'm going to come up with negative 3 and negative 15. You can check them, but I'll ruin it for you now. They are right. Okay, I will say, and you're going to do this one on your own, be careful with the signs. The ones that I have done have ended up being positives, but sometimes it's a negative number that you add to itself to get that middle term. So just be really careful with your signs. Number 3, I'm going to do for you though. So the first step, if you notice it's not a perfect square trinomial, and hint for you, this last number, the c value, has to be a perfect square before you can even consider doing this doing a perfect square trinomial. So 104 is not a perfect square. There's nothing times itself that gets me that, so I'm going to move it over. And I've got x squared plus 20x equals negative 104. Now, let's see. From there, I've got to complete this square, so I left some space. I need to think what number added to itself gets me 20. Well, I know 10 does. Once I find the number, I square it. And that's what I add to both sides. Realize if I would have gotten negative 10, when I square that, that means times itself. So negative 10 times negative 10 would still be positive 100. So if you get a negative number as the number you come up with that you're trying to find, realize that when you complete the square, you're always going to be adding a positive number. Okay, be careful. That applies to number 2. All right, let's rewrite this. So that would be x plus 10, my binomial squared, equals negative 4. I'd square root, and I would stop right there because I can't take the square root of a negative number. So I know this has no solutions. Yay, that's easy. So if I were to graph this, this parabola would never cross the x-axis. Okay, so that's completing the squares. We're going to spend 2 days practicing this in class because it is a little bit more challenging than the first 2 methods. I want to fill in some tips for success at the bottom, though. Please make sure that you take the time to get the correct number that completes the square. So like the 81, the 100. Be careful. If you add the wrong number, it's just going to throw the whole thing off. Again, this should always be a positive number, so if you are doing like a negative 81 or a negative 100, that's not right. And if you do the wrong number there, it's going to throw the whole thing off. You'll never get the correct answer. Okay, so take the time to get the right number there. One of the biggest mistakes that I see people make is this second tip here. They forget to use the plus minus sign when they take the square root. So they only come up with one answer when there is usually 2. Okay, so do not forget the plus minus sign. Do not forget to write 2 different equations like I did here. So that way you can come up with both answers. All right, so that's method number 3. Next time we will do the 4th method.